The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Welcome to today's Silverlight Show webinar. My name is Emil and I am pleased to introduce today Brian Noyes, who will deliver his next session from the series on WCF RIA Services. This session will be dedicated to plain old CLR objects domain services, and it's definitely a long name. Before I give the word to Brian, I want to remind you that we're giving away three Silverlight Show t-shirts to those of you who tweet this webinar using a hashtag. The hashtag is webinar Silverlight Show. I'll write it down also in your chat panel. Okay, with that, Brian.
Yes, I will take it away.
Yeah.
Okay, welcome everyone. And this session, as the title implies, is on building POCO, short for plain old CLR object. If you don't recognize the acronym, WCF RIA Services. So this is the fourth webinar in a series now that goes in parallel, somewhat in parallel with my article series that's also out on the Silverlight Show and also available as an ebook there on Silverlight Show. This one departs slightly from the written series in that I didn't cover in any detail in that series doing POCO domain services. So this is to supplement the written stuff there and give you an idea of how to deal with things if you don't want to use basic entity framework base classes for your entities. So a little background on myself. I am with a company called iDesign. We're a .NET architecture and design consulting and training company. I'm also a Microsoft Regional Director for the Mid-Atlantic region. That is the Washington, D.C. and surrounding states here in the U.S. And I'm also a Silverlight MVP. Do a lot of writing and speaking. The important stuff here is my contact information. If you don't get your questions answered here at the end of the session, we will reserve about 5-10 minutes for Q&A via the chat window. But if you don't get your question answered here, feel free to ping me offline via email or Twitter there. And with that, let's talk about what we're going to talk about. The first thing, I'm going to give a very brief RIA Services overview. It would be best if you are viewing this one and have at least read the first article or two in my series or seen the first of the webinar series here on RIA Services, where I give a detailed overview of RIA Services. I'm not going to repeat all that here for time's sake, but I do want to just get everyone in the frame of mind, and I'll just quickly summarize what RIA Services is about. But then we'll quickly shift our focus to just a particular form of RIA Services, which are those that are defined not based on a full entity framework model, but ones where you want to have more complete control over the entity types that you're dealing with, and possibly have your own base classes or maybe even no base class on those entities, and also maybe not even use entity framework, maybe use traditional ADO.NET or Hibernate or even other forms of data access, such as calling some external service and pulling things in as data contracts and then passing those on another step in the tier via RIA Services. So we'll talk about how you go about defining those domain services and what they look like. We'll talk about some particulars on the entities you're going to define that are required, but ways of dealing with that. And then we'll also talk about dealing with concurrency. When you're doing your querying and updating of data as entities, you often need to know what the original state of those entities were to change the way you go about doing your updates. So we'll see how you can handle that. And then finally, we'll talk about related objects. The world is not composed of isolated objects that have no relations to others. You often have things like parent-child collections and relations to other objects, so we'll talk about what's required to facilitate those. Okay, so the first thing here from a big picture perspective for those that are new to RIA Services is all about building multi-tier line of business applications, primarily for Silverlight, but also to a certain degree with ASP.NET on the server side. There's some capabilities there with the RIA Services Toolkit, and the important new thing they highlighted at the recent Build conference that is coming out, it's not fully released yet, but they're getting close, is the WCF jQuery capability, which also gives a RIA Services experience in JavaScript on the client side for ASP.NET or any web application really, but for this audience, primarily ASP.NET type of thing. So basically the idea here in pictures is most of us are used to building hopefully layered applications at least with presentation, business, and data layers separated out, but possibly only a two-tier kind of architecture like is shown in the diagram to the right here. What RIA Services lets you do is get into that more distributed world of Silverlight clients and ASP.NET client-side script clients and let you communicate, write your presentation layer, and let it communicate with those back-end business and data access layers. But it basically injects in between some infrastructure. Think of it as a big data pipeline in the sky that gets your data back and forth from your presentation layer to your back end. And it's not just about data. You can invoke arbitrary service operations on your back end via RIA Services, but it is mostly about kind of CRUD-oriented operations working with data, and makes it really seamless and easy to do those things. Now what we're focusing on today is this idea of POCO domain services. If you've watched any of the other webinars or read my article series on RIA Services, in all of those, mainly for expediency, I used a base class in RIA Services called Link to Entities Domain Service. And this is basically a base class that is aware of Entity Framework. It's aware of the query and update patterns of Entity Framework. And what it does is it encapsulates an object context object under the covers in the base class, and just makes it so it's a little bit easier to set up the query and update patterns working with an object context. Now, there's a number of downsides to using that thing. One is that it obviously only works with Entity Framework. And if you're familiar with the different modes of Entity Framework, you've got database first, model first, and now new in Entity Framework 4.1, you've got code first ways of dealing with Entity Framework. Object context that's mentioned in the bullets here only applies to database first and model first usages of Entity Framework. And the code first use of Entity Framework is becoming very popular because you don't have to have a model at all, but therefore you also don't have an object context. And so for code first development, the Link to Entities domain service wouldn't even be applicable. The other place is not everyone uses Entity Framework, as I mentioned. You might use Hibernate or some other form of data access, read things in from files. There's any number of ways that data might get into your back end that you want to access from the remote client in the Silverlight app. And so for all those other situations other than a database first or model first Entity Framework back end, you need to be able to deal with that. And the way you do that is to use the domain service base class that's actually the base of Link to Entities domain service. Once you do that, you don't get as much code generation on the server side as you do, as I've demoed in previous sessions. Normally when you set up a Link to Entities domain service based class, it does some code generation for you on the server side to set up the CRUD operations on top of your model objects. In the case of a raw domain service that we're going to be looking at today, you've got to code it up all by hand, but that's because it's making no assumptions about how you go about getting data into your app. It's up to you to write that code against whatever type of data access you're doing. But the benefit of this is now you own your object model. One of the big complaints about using database first or model first development with Entity Framework is that you don't really own your object model. You have to inherit certain base classes from Entity Framework. You have to have certain coding patterns in those, and they're generally code generated for you, so you don't have complete control over the structure and base classes and interfaces and coding patterns of those entity objects. Whereas if you go with a POCO domain service, you're in complete control. And if you have your own framework base classes that you want to inherit from, party on, you can do that stuff very easily and still leverage all the other aspects of RIA services, such as the client-side validation, the query and update patterns, the fact that it sets up the service pipeline for you and makes it so you don't really have to know anything about WCF. All of those benefits I've talked about in previous sessions, and you still get all of those. The only thing you have to do is a little bit more work on the back end to define your entities and to define your data access that populates those entities and does the updates from them. So when it comes to defining entities, basically, like I said, you're in control. Those entity classes have virtually no requirements on them. There are a couple of small things you have to do in the form of attributes to decorate the certain properties on your objects so that RIA Services knows how to handle them when it's transferring them back and forth across the wire. The one that you always have to do on an entity before you can pass it via domain services is to put a key attribute on some property on that object that uniquely identifies it, like a primary key in the database, but it doesn't necessarily have to correspond to that. But it needs to be something that's going to be unique across all the instances of that object type that get transferred through your domain service. So typically this is an integer or GUID type of property that's your unique identifier on that object, and you put a key attribute on it. There's a couple other places later on I'm going to talk about a few other attributes that you'll use when you're dealing with related objects. One thing to keep in mind as far as all these objects are concerned is that you don't have to put these necessarily on the entity type itself. You can define a separate metadata class, and I've covered that in previous seminars on the entity framework-based models. You can have a separate metadata class that you add on the attributes in a metadata class and then relate that metadata class to the primary entity. And that's exactly what you have to do when you're dealing with code-generated entities in Entity Framework. You can still do that same thing with your own POCO entities if you don't want to pollute the properties of your entities with these attributes, as some people view putting those kind of attributes on there. But if you're okay with just putting some attributes on there that only RIA Services is going to care about anyway, then you just put it on your primary entity object, and that's what I'll be doing today. So let's go ahead and jump to some code and start seeing what this stuff looks like. The first solution I'm going to go to here keeps it simple. We'll start simple and then we'll get into a more full-blown example here. But the first step is going to be, well, you can sort of start in either direction in this case. But bottom line is you always need some data to work with before you start defining a domain service. So really you want to focus on what are the entities, the data objects that I'm going to pass back and forth across the wire. So in this example, and the examples I'll be doing today are a task-based system. Think about, to-do lists, or in this case, it's based around a more full-blown scenario using samples where you have tasks and time entries and customers and users and projects, kind of in a work item management type system. But for this demo, we'll just look at a task class, and it has a identifier, and this is where that key attribute comes in that I was talking about a moment ago, is that you just have to have some sort of identifier on the object that you can mark with the key. The rest of it, you can see here, this is just a plain old class, no base classes, no interfaces, nothing special about it. It's using just auto-implemented properties in this case. They don't even have to implement iNotify property change or anything like that if you don't require it on the client side or on the server side. It's just a simple object with properties, and that's perfectly valid to be used with RIA Services here. Once you've defined your object model types, then you have to define your domain service and how you're going to expose that to the client. So unlike previous demos, this is where I was talking about the base classes. Previous demos, all the ones I showed had the link to entities domain service base class here. This one just derives directly from domain service, and there was no code generation for any of what I'm going to show here. This was all just typed by hand as a normal coder in defining this service class. The one thing that is still key is this enable client access attribute here. That is the thing that tells it to do code generation onto the client side, which is the whole point of RIA Services. Now to get to this, you can still go through the wizard. In the end, once you're done with the wizard, this is just a new class in your project with the appropriate base class and the appropriate attribute. But if you want to go get that through a more wizard-driven experience, you can go into your project and say add new item. It's very similar to what I've showed in previous sessions. In the web category, you would go and select the domain service class project item template. And I'll just add a new one here so you can see, what do you get when you start. You get the same dialog I've shown in previous sessions, but in those, there was an entry in this drop-down in the middle that had all of the Entity Framework models entity classes that were defined in the project or related project or reference projects. In this case, there's none of that because there is no model here. In fact, I'm just using the task type, and there's no real data access in this particular example. So your only option is an empty domain service class. And this checkbox up here corresponds to that attribute that I said is important. So, pretty much this is just a wizard-driven way to save you from writing, this much code by hand after doing add new class, and adding a few namespaces that you'll need as well. But actually, personally, I don't ever put using statements inside of my namespace, so I almost would prefer to write this by hand so that I get my namespaces in the right place. So I'll just delete that one off since we're not going to use it here, but that's the wizard-driven way of getting to here. But once you have that basically empty class with the right base class and the right attribute on it, now you're ready to start doing RIA service stuff. So the first thing you'll have to do is say, okay, where am I going to get these data objects? In this particular example, the task object, where am I going to get those from? Now, just to emphasize that you're not tied to any particular data access strategy, this one I'm actually just using a static collection held in memory as long as the process stays alive, where I store up a list of tasks. And then from there, RIA services are mostly about CRUD, as I said. So what you'll want to do is define the create, update, read type, or create, read, retrieve, update, and delete. That's what CRUD stands for. Create those methods within your class. So you can see down here the get all type of method. In domain services, you can define a iQueryable of T or iEnumerable of T type method, and it will treat that as the thing that gets me a collection of those types. You can also, just like with the full entity framework model type of thing, you can define methods that return a single instance of an entity type based on some criteria, and it will treat that as something that the client can call as well. For the add, there is a naming convention, is what they're actually keying off of. You can prefix this with add or insert, or I forget, there's a couple other naming conventions that they'll recognize as the thing corresponding to the insert type of operation for your CRUD operations. Likewise with update, modify, and a few other variations there that they'll recognize for update, and delete, remove, and a couple other variations that they'll recognize as being the delete part of a CRUD operation. These always will take a single instance of whatever entity type you're working with. And as I've mentioned in previous webinars, what really happens here is these are not the directly exposed service operations. The actual service operation that is exposed is a base class method called submit. That's the real exposed service method that the client's going to call, and it's going to pass down a change set that can contain a collection of insert, update, and deletes, possibly on multiple different entity types. And the base class will iterate through that change set and call the appropriate insert, update, or delete operation for the items in the change set. So these methods are called by the base class. This is the method really exposed to the client through services. But typically you'll want to deal at the single object instance level anyway, so you just define these insert, update, delete type operations. And then from there, if you're in a domain service, the implementation of all these methods is totally up to you. However you go get that data from wherever it is with whatever technology, you write the code to do that. So in this case, because I'm simply working with this static list of tasks in memory, for my get all tasks type of method here, I just return tasks as queryable since it's actually stored as a list. Now, if I do this, what is the point really of doing this as an iQueryable? As I've talked about in previous webinars, RIA Services supports basically deferred execution from the client, where the client can set up an expression tree that includes things like a where clause and order by clause and a take or top 10 type of clause to just get a certain number of items from the underlying collection. And whenever you do that from the client, if the method you're actually invoking, such as the getTask one here, is exposed in an iQueryable, the RIA Services client code will send that expression tree down, and then that expression tree will be evaluated on the server side. Now, if you're working directly against Entity Framework under the covers, that can pass all the way down to the database and turn into select where top order by type clauses in SQL. But in this case, since we're just working against a list in memory, we have to turn that into an iQueryable, and there's a link extension method that will do that for us. You still get the benefit that the client can send down an expression tree that will actually filter on the server side the resulting set that is transferred back to the client. So if there's 1 million items in my task list and the client only wants the top 10, if you didn't do this as an iQueryable, it would actually have to return all 1 million items to the client and then have the client do the filtering. If you define it as an iQueryable, the client can say, take 10 as a link operation on the collection it deals with on the client side, and that expression will be sent down to the server side. And even though it will still have to grab all 1 million items from the task collection in this case, it would then filter its server side down to just the top 10 and return those to the client. So obviously a huge bandwidth savings and transmission time savings there in terms of getting the data to the client if they formulate an expression. You don't have to do that. I could have made this an IEnumerable, and then it's going to just return the whole thing. But just be aware of that aspect of iQueryable as a very important feature of RIA services, whether you use a link-enabled provider as the data access layer or not. For the add, you can see I'm just doing a straight add into the collection. Obviously, for something more production, you would want to check for dupes and not accept the add if there's already an existing task of that ID. Likewise on the update, in this case I'm doing a select basically with some link here into my task collection, trying to find the matching item. If I don't find one, I throw an exception because I can't update something that doesn't exist. But if I do, I just push all the values of the properties of the one that was sent down by the client into the one that's already in the list as the left side assignment there. And then delete task is very similar, where I just do the where clause here, using some link into my task list, find the appropriate one, complain if I can't find it, otherwise remove it from the list. And that's basically it, so basic CRUD type of operations using whatever your underlying data store is to insert, update, delete those things, or to retrieve a collection or a single item from that collection as operations. Now, just like I've described in previous seminars, once you've defined this domain service, and the other important part is in your client project, your Silverlight project in this case, but again, in the future this will also apply in a slightly different form to ASP.NET Ajax client code. You have a link to the server-side project that is the basis for your calls. And that at compile time now, when I go and build this project, some compile time magic happens. And over in the client Silverlight project here, if I show all files, we've got this generated code folder, and I've got the web.g.cs generated code file that gets a definition for the task. Now, important thing to notice here is I had a true POCO on the server side. My task on the server side has no base class, has no interfaces. The only requirement is to have a key type property with the key attribute on it. But the server side, or I'm sorry, the client side code generated one still gets the rich infrastructure defined by the entity base class in RIA Services. So that implements iNotify property change for you. That implements iNotify data error info so that you can do the validation features that I talked about in the previous webinar. So you still get the full richness of the client side framework regardless of how the entity was defined on the server side. So the other thing you get, of course, as talked about in previous ones, is your domain context. And this is the proxy object, if you will, from a services perspective. This is the thing you call through to talk to your domain service that's on the back end. And it is going to expose collections for each of the entity types that you've defined. And this is where I said you can query this collection or really set up a query expression on this collection to do order bys and filtering with where clauses and so on before you execute a query. Okay, so then what does the client side look like for this? Once I've done the compile, I want to go ahead and display some of that data. Now for this example, I'm not doing MVVM and anything more fancy. The next demo I'll show has some MVVM pattern in it. But this one, just in the code behind of the main page, news up an instance of that domain context. When the main page is being constructed, it executes a load operation. The load operation takes a query object, which you also get off the domain context. This one will return all of the tasks, but this is where I mentioned that I could formulate a where order by any kind of link operation on the resulting query from this method, and then that formulates the expression tree that would be sent down to the client. And I've demonstrated that in previous sessions. In this case, I'm just going to get back all tasks, and I go ahead and bind that task collection to the item source. Again, as I've mentioned in previous sessions, at the point where this line of code executes, that task collection is actually empty because this load operation is actually an asynchronous method. So it's not until the load completed callback handler down below fires that this task collection actually gets populated. That happens asynchronously, but RIA Services takes care of marshaling that population onto the UI thread so nothing blows up. And at the point where it does, collection changed events fire, and any bindings that are there or the item source itself here will be notified of those changes, and it will refresh the data on the screen. So even though at the point this line of code is executed, most likely the load has not completed, you'll still see the data pop in asynchronously a moment later. And then if you handle the completed callback, you have an opportunity to do your error handling. And I've talked about that before. You have a flag to check if there was an error. You have an error property on the operation that gives you the underlying exception, and you need to mark the error as handled, or it will throw an unhandled exception on the thread, which can blow up your Silverlight application. So with that code in place, I can run this thing, and we should see it start up. And if you watch closely, when I click on the page here, the grid's going to come up initially empty, and then a moment later, the data will pop into it. It happens pretty quick there, and with the lag of the webinar here, you may not have even seen the lag, but it does show up with no rows initially, and then a moment later, the one row pops in there. So that's the basic retrieval of that data. Now, if I want to do CRUD operations, in this case, I support adds, so I can add a new empty thing. Basically, the ID is assigned, but I don't have any kind of title or description. I can just put some garbage text in here and edit this thing. Now what I'm really doing at this point is I'm editing the entity that's being managed by that domain context, and it's still holding a reference to it, as is the data grid here. So I am directly editing it. That domain context is monitoring the property change events on it, so it knows that this thing is now in an updated state, and it knows it needs to send it down to the server whenever the client chooses to do so. So I've got a save button up here that when I click that, it's actually going to execute a call to the server to send down any added, deleted, or modified entities that are being managed by that domain context. So the code that's associated with that is just down below here. You can see that when I did the add, it's really just to set the task ID in this case, since we don't have any kind of identity field backing it that would do it automatically for me. I've just got a little chunk of code here that finds the last item in the collection and does a +1 on its ID to set the task ID so that those remain unique. That can be done server-side when you're using a database with an identity field. And then I just do an add on the task collection that's exposed by my domain context object. And at that point, it knows that there is a new entity and it's in the added state. But then once I start modifying those fields, it still says, well, add is more important than modified. Everything that's added is modified. So it will actually be sent down to the server in an added state. And it will invoke the corresponding method that I showed before right here on the domain service. Now, the code that actually causes the server call to happen, going back over to the client side, is not until I click that save button. And what you do is you call submit changes on your domain context object, and that will take all of the added, removed, and updated items that have been modified on the client side and send them all down in a batch to that submit operation with the change set that I pointed out earlier. This one too follows the same kind of async pattern. All methods on your domain context that call the server are asynchronous, and they have that same pattern of having an operation that has the error information for you to deal with it, as well as various other properties associated with the type of operation. Okay, so that's the basic CRUD pattern, and it's very similar. If you've watched the other webinars, it's very similar to what I've showed before. On the client side, you don't really know, and you really shouldn't know, what the implementation details of the back end are as to how the entities get populated and created. The client-side entity here looks no different whatsoever from a client-side entity that was an entity framework entity. So that's totally transparent to the client how that all happens on the back end. For updates, if I were to do those, let me just run here one more time. Now you can see that data is still there. In this case, it's because down in my system tray here, Visual Studio kept this ASP.NET development server running. So the app domain was still around, the static variables were still populated. But if I shut this thing down, then we'd go back to that one hard-coded entry that's down in the base class. If I modify one of these, we'll just make this all H's so it stands out, and do a save again. Now it knows that entity is part of the collection that was returned by the server, but it's now been put into a modified state. And so if I go put a breakpoint in my update method, where's my domain service? Here's my update method. I'll put a breakpoint there, go back over to the client and hit save. And you see that we end up in that update method because it recognized that as a modified task. So it sorts those out based on a flag it tracks on each entity, whether it's insert, updated, or deleted, so they can invoke the appropriate domain service method. That's the basics of doing POCO domain services. Now, let me talk about a few other aspects here and show a slightly more advanced sample. So I'm going to go back to the slides for a moment, and let's go to the slideshow. Now, what if you want to deal with concurrency? And by concurrency here, what I mean is original values versus current values. That can be important. Now, one form of concurrency is just detecting whether the item that's in the database has been modified by someone else while this client was modifying it. To do that, you need original values to be able to detect. And so RIA Services can automatically round trip the original values. When it calls down into that domain service like I just did with the update, it can send down the original values as well. Now there's a couple ways of dealing with this. One is that you don't necessarily have to round trip the original values. You can treat the current values in the database as the original values you want to compare with. So that would be a last in wins type of scenario, is that if you do a last in wins type of concurrency, then all you want to do is see, has anything changed from what the database currently has, and if so, I need to update those properties. The other aspect of concurrency would be a optimistic concurrency type of approach, where you say, if the values in the database are different from the values that were the original values for this particular client, then I want to reject the change in a similar fashion to what ADO.NET datasets and table adapters do by default. So, but for both of those, you have to have some clue of what the original values are. So let me go to another sample solution here. Now this one is a little more complicated. I wanted to show one that's doing some real data access, but not just based on a normal entity framework model. In this case, I'm using the new Code First features of Entity Framework 4.1. Now, I could easily do a whole session giving you an intro to Code First. Don't have time for that here. I just want to give you the essence of it. What I have is, first and foremost, the reason you do Code First, similar to the reason you do POCO domain services, is you want to be in control of your model and the model objects themselves, and not have them code generated by Entity Framework. So you have similar motivations of doing either Code First or POCO domain services, so they go hand in hand nicely. In this case, I've got a very similar entity here. You'll see a little bit more going on here, and I'll explain the different parts. If you just look at the middle of it, it's the exact same task class, no base class, have a key property on the task ID field, and a few other properties that I want to be carrying back and forth to the client. Just ignore the rest of it, the child collection for now. I'll get to that in a little bit. So if I want to, send this thing, and also ignore this round trip original here, you can guess what that's related to, but I'll get to it shortly. So just pretend this thing just has this stuff on it. In fact, I can comment out the rest for now since I'm not using it. Okay, so now we're really back to exactly the same kind of task we were dealing with before. If I want to go ahead and transfer that now, or really I want to read these out of the database, the way you use Entity Framework 4.1 is you define a class that derives from DB context as opposed to object context, and then you expose collections that are DB sets of a given entity type that you control the entity, and that's basically it. Other than this override down here is kind of important for managing the relationships between objects, and also for mapping things that aren't one-to-one property names. Any Framework 4.1 and the Code First stuff uses a convention-based approach. So if I have a task table and all of the property names of my task type map one-to-one to the column names of the corresponding table in the database, then I don't have to do anything fancy. But you can see things like this pluralizing table name convention that I am removing. That is on by default, and it basically says if you have a task collection, it wants the table name to be tasks in the plural sense. In my case, my table name is task singular, no S on the end, so I have to remove that pluralizing table name convention. And this is part of what's called a fluent interface of Entity Framework 4.1. You can find some good documentation on this in MSDN about using the fluent interface to manage properties and mappings to the database, to manage relations, and so on. So I won't go into details there, but basically this is all that's required. This is my entire data access layer here, is this one class, mostly just the DB sets, but then some overrides that take care of mismatches between the database and the object model. Okay, so that's the underlying data access that's going to go on. For my domain service itself, similar to what I showed before, it's just a class that inherits from domain service as the enable client access. Very similar to, actually let me switch here, make one switch here since I made those changes to my object for now. Comment out the stuff that's dealing with the child collection. And so if I just return the context, which is a DB context .task, that DB set that's hanging off the DB context, it acts very much like a object context collection. I can return it as an iQueryable. I get deferred execution all the way down to the database in this case. So if the client sends down a where clause and an order by clause, the underlying DB context class will turn it into where clauses and order by clauses in the SQL that executes at the database level. My insert, update, deletes look very similar to what I had in the last demo. The only difference here is that instead of working against my static list in memory, I'm working against that DB context, DB sets, to actually talk to the database in a form, or at least form the expression trees that will talk to the database. And then I have to call save changes here to get it to actually talk to the database and make those changes. So very straightforward kind of data access going on here using Code First and the framework features. But otherwise the code looks very similar to my last demo. Now, in terms of the concurrency, the one additional thing I'm doing here is notice on this update task, well, ignore this line for now. Again, that relates to something I'll show in a moment. What I'm doing here is I'm actually going out when an update comes in, a single task is about to be updated. I go and do a retrieval actually in the task collection, matching on the task ID, basically finding the one from the database, the current values in the database, if you will, and then I want to update that one with the current values of the task that's coming down from the client. Now, if you do it this way, the advantage is that Entity Framework is smart about this, and say that object had 50 properties, and only one of the properties has actually changed. If you do the comparison work to say, is the current value of this task coming down from the client equal to the one that's in the database, which is what my set unchanged properties helper method here is doing, then it will formulate a SQL statement that will only do an update to that single column. If you use the link to entities domain service base class I mentioned early on, when you use database first or model first development in any framework, the problem with that base class is it just blindly assumes that all properties have changed, and so it's not doing this kind of comparison I'm going to show here with the helper method to make sure that the update statement that executes down at the database level is efficient as possible. This little helper can take care of that, and you could do that even if you weren't using code first development. So I'm taking the one sent down by the client, I'm looking up the current matching row in the database, and then I've got this helper method that basically loops through and uses a little bit of reflection to get the value of each of the one that's coming down, or I'm sorry, the one that's in the database is the target, the one that's coming down from the client is the source, and it does a comparison to say, are the property values equal? If so, then don't set the one from the database so that it knows that one is unchanged and can formulate the appropriate SQL statement. So that's just an optimization you can do, but this one doesn't require any round tripping of values from the client. This is that last in win scenario, but an efficient update for the last in wins. Now, if you actually want to be smarter and do optimistic concurrency, what you can do is start round tripping original values. And to do that, go back over to my task object. What you have to do is put a round trip original attribute either at the class level like I'm doing here, in which case it will apply to all of the properties, or if there's just discrete properties you want to round trip originals on, say the description here, you can also use the same attribute at a property level. And it's just an instruction to RIA Services when it goes to send the data to the client, and more importantly, when it goes to send data back from the client, it knows to hold on to the original values when that object starts changing and to send those back down in the change set as well. So when I turn that attribute back on, if I go back into my domain service here and just uncomment this line of code. Now, I'm not actually in this demo, I'm not actually doing anything with those values, but you can see what you can do is on your base class there is a change set property, and that corresponds to the change set that comes into that submit method I showed earlier. On that, there is a get original method, and you just pass in the task that you're dealing with. It's going to use the key property to get the original one that comes down in the change set and just return that to you as another instance of your corresponding entity type. So if I run similar scenario to what I did before, I'll fire this thing up and I'll make a change to one of the fields here, say the title field, and then my save button is hiding way over here to the right. I'll go ahead and press save, and we should hit that breakpoint. Now you can see here's my task that's coming down. It's the modified one. You can see the title there is test 222, but my original that I get out of the change set, the title is test. So you could use that as a way of round tripping from the client instead of having to go back to the database and only see the current value. And now with this original, you could also go to the database, get the current value, look at the original value, see if they've changed, and throw a concurrency exception, for example, if you have an issue with that. Or you could use the values of the original to do similar things to what I'm doing here with set unchanged properties to figure out only which ones have changed and only do updates to those. So that's how you can round trip concurrency information as a simple attribute on your entity type, round trip original, and then to retrieve that information, change set.getOriginal method in your domain service. Very straightforward. All right, one last topic, and then we'll jump to questions, and that is dealing with relations. Like I said, most objects are not islands of information. They have related objects. You may have a customer with orders, with order details, and so on. So in my particular scenario, let's say a task has a collection of time entries. That would be a child collection. A task can also have a related customer that may be null or it may be populated if that task has an associated customer. So that would be referred to often as a parent object or just a related object reference. In the object model of my sample here, If I go back to my task, the stuff I commented out, I'll bring back in this property. And let's make sure it's an empty collection, not a null reference, when the object is constructed. So you can see this is just a list of a child object type, a child collection, and we populate it with an empty list initially. What you have to do for RIA Services to be happy with this and to send the objects across the wire correctly is that you need a association attribute. And basically what this thing is doing is you're giving a name to the relation, and behind the scenes RIA Services is going to set up some extra objects to kind of track these relations. You say what is the key property on this object, the task, which is our task ID, and what is the key property on the related objects, which is the time entry ID. And that gives RIA Services enough information to kind of relate all these things behind the scenes, transfer them across the wire, and rehydrate the same object graph basically on the client side with all the relations intact. The other thing you will need is an include attribute, and this is an instruction I've covered in past sessions that basically tells RIA Services I do want to serialize those child objects across the wire when I serialize the parent object, the task in this case. If you leave include off, the association will still be intact, but the client would then have to retrieve the time entries separately and then populate the collection on its own, in which cases RIA Services is not really round-tripping any of that stuff anyway. So on these child collections or related object type of properties, you'll typically have an include and an association attribute like this. And with those in place, now in this case I've got some kind of crude code doing this. If you download the sample code later, which I will make available on the Silverlight Show site, and I'll also do a blog entry about it on my site, which is briannoyes.net. I've got some kind of crude child collection population code here. The reason for that is because I was tinkering around with my demo as a good presenter never should, and basically broke some of my data access code and the way you set up that Fluent interface stuff for related collections. So I'll leave this code in place this code in place once I upload the demo because it's what I did quickly to get it working here. But I'll also fix the relations in the code first stuff so that this method is no longer needed. But basically what this is doing, if I go up above here and change my retrieval method, you'll see I'm doing this get tasks with time entries. And I'm doing the context.task to get the task list, and then I'm actually making it execute the query to get those into memory as a list by doing a toList on it, and then I'm looping over each one and getting all the related time entries in sort of a manual way. So there's a whole bunch of round trips to the database here that's kind of inefficient. Like I said, I'll fix that by the time I upload the final code there. But ultimately, I'm getting a collection of tasks with their time entries populated and returning that as an iQueryable. And then that gets sent back to the client, similar to what I've already described. On the client side, I've got some very crude user interface here to display that stuff. If I go ahead and run here, we'll see it on the screen, then I'll just show you the code that's doing it. If I select my first task there, you'll see the time entry collection for that populates, and there's just one entry in the database at this point, this test time entry that's directly associated with this task. If I have another task up there and select it, there are no time entries associated with that. So, you can see that the time entry, the related association, is being populated, transferred to the client, and the object relation is there between those two objects. And the only code that was required on the client side to accommodate that, first off, once I define that, and I do have to also have, I should point this out, you'll also have to have a retrieval method for that entity type so that RIA Services knows to code generate that type on the client side. So now in my generated code, there is both the task type and the time entry type code generated on the client side. The other thing in terms of binding on the client side, if I go to my task view here, all I really did to display that extra stuff is I put a data grid in here and bound to the selected task.time entries. So you can see I'm actually navigating through the time entries collection of a task object to get to the time entries that came across the wire. I don't have to do any kind of explicit load for those. I've still got the same load code I showed before, or similar load code, where I'm just doing a load on the task query and getting all tasks. I'm not doing anything explicit with the time entries because they come across with their related tasks due to the include and association attributes. Right? And that's basically all there is to deal with associations in these entities. With that, let me just kind of summarize here, and then we'll jump to Q&A. So you can see by using a domain service base class and your own entity types, you kind of get freed up from the obligation to have an entity framework base class and do entity framework database first or model first development. You can do code first, as I did in the last demo, or you can use your data access technology of choice to populate your own custom entities with whatever base classes and functionality you want to put in those things. You still get all the client-side framework features that I've talked about in previous sessions. There's no visibility on the client side of how those entities were populated or defined on the server side. You just have those rich RIA service base class entities to help you out on the client side. If you want to read more about RIA services in general, there's the link to my 10-part series on the Silverlight show. As I mentioned, I don't have a link here, but you can also find in that series they have turned this into an ebook if you want to just get a PDF version. It's also out on Amazon.com as a Kindle book if you want to read it that way. As I said in that series, I didn't actually go into any detail on what I've covered today on POCO domain services, so this is your source for that at this point. With that, I would be happy to answer any questions that people have. So let me bring back up the chat window here and email if you can start feeding any questions through. I'll do my best to answer those.
Yeah, okay, so the first question is WCF RIA Services compatible with WPF?
Yeah, let me undock this thing so I can see these better. Okay, now I'm starting to see the questions there. So is it compatible with WPF? My answer to that is I wish. I've asked the product team that many times. They always say that it's still on their list, their backlog of things they would like to do. But with the passage of time, I presume that it's getting pushed further and further down the stack. With the announcements at the Build conference about Metro, and just with the fact that all new functionality and all new capabilities coming out of the team seem to be going towards Silverlight and not WPF, I personally would not hold my breath for WPF support with RIA services. All right, the next one is, can you use the POCO template generator in EDMX and then not have to worry about doing all the detailed coding in the domain service? You can use T4 templates to generate your POCOs, but the server side, in terms of the domain service class itself and the CRUD operations in that service, you have no code generation of those methods unless you're working against an entity framework EDMX object context-based model. Now, your question says if you're using the T4 template generator for EDMX. If you're doing EDMX, then you've got an object context, and you could use the link to entities domain service base class, and then you would get some code generation of those CRUD operations. The thing to be aware of with that I've mentioned in previous sessions is that those are really just a starting point anyway. They're about 2 to 3 lines of code per method with basic query patterns. And for complex object models and stuff in real-world applications, you usually have to go modify those methods and add things to deal with child object collections and various other things. So the code generation that you're getting out of RIA services, even when you're working with an EDMX, is not worth it, in my opinion, to steer me towards that direction. If I want complete control of my model, I'm going to go with POCO model and take care of it and just code up my domain service by hand. All right, the next one here, how do you keep track of your IDs when there are multiple users pressing add at the same time? Okay, well, if you look at the code in the second demo that I showed, I'm not populating IDs there at all. When I do an add on the client side, I just new up an object and I set whatever other properties I want, but I just ignore the ID on the client side when it's an add. When I press the button that calls submit changes on the domain context and it sends down that change set, when I do an add on the underlying, in my case, DB context, or the same thing would apply to an object context in the other forms of Entity Framework. Entity Framework is smart enough to see that that's an add. It will go do the insert at the database level, and the database will auto-generate the ID because it's an identity column. So if you're dealing with identity columns, you can just let the object get pushed all the way down to the database. Once the ID has been generated at the database level, Entity Framework is going to repopulate that object. And the other thing that's kind of spooky, I guess you could say, about this, it's not apparent from looking at the signatures. If I go back to my my code here in my domain service and look at, for example, my add task method here, it's a void return type, and that would lead you to believe that nothing gets returned to the client. Well, the fact is, like I said, these methods are not invoked directly by the client. These are invoked by that submit operation. It turns out the submit operation does return something to the client, and so when you do an add like this and the ID is generated on the server side, the modified task is sent back to the client, and the client-side version of it is updated. So as long as you centralize your ID generation on the server side, whether it's done at the database level or through some ID generator you put in your domain service, then it will work out with concurrent clients. I hope that was clear. If not, you can follow up with me by email or via Twitter. All right, lots of questions streaming in. I'll keep going here for 5 more minutes, and then we'll have to wrap, and I'll follow up on any I don't get to through email after the show there. All right, so the next question, let's see here. Oh, a rephrase of the previous one about EDMX templates, and it basically said how can we use EDMX template generation and not have to worry about coding all the CRUD methods. Actually, that is kind of the same question I answered there. So you will have to code the CRUD methods even if you do the initial code generation with a link to entities base class, because for anything real other than 1 or 2 lines of retrieval code, you often have to go modify the code generated stuff anyway. Question: can we call one WCF RIA service in another RIA service? Not really. As a class, you could certainly invoke a method on a domain context or a domain service object from another domain service, but in terms of making multi-hop calls, the way you call a domain service normally is through a domain context, which is only code generated in Silverlight projects. Now, a domain service itself can be exposed as just a normal WCF-like service, really a REST-based service, or a SOAP-based service. I cover that in part 10 of my RIA Services article, so I'd recommend, Mohammed, you go check out part 10 of my article series. It talks about the additional endpoints that you can expose from a domain service, and then definitely you could have one domain service be a client, just a service client basically, and could even co-generate through add service reference a proxy to be able to go call that SOAP-based domain service from another domain service. Next question is, could you show us how to expose the task object from the time entries class? I unfortunately don't have time to go into detail on that. You could have a back reference. What the question is referring to is often in an object model like this, you would have, instead of just having a task ID, if I go to my time entries class right now, let me go expand here and go to my time entry. You can see right now I've just got a foreign key type of property from my time entry back to the task. I could also have this as a task property that points to, by object reference, to the related task as a parent. That will definitely work out as far as RIA Services is concerned. I don't have the time to code it all up here. I will try to do a follow-on blog post or something, or if you shoot me an email, I'll try to point you to a sample that shows how that would differ. The same things apply, that you would have an association attribute on that to relate it to the thing it's pointing to. So you would have to give it a name, give it an association name. You would say it's based on the time entry ID key in this object, and it relates to the task ID property on the other object. So it still has to have those keys to relate things, but the actual property on this object could be of type task. All right, next one, let's see here. It says, I am not a real web developer, but can we use HTML5 with POCO services somehow? Yes, definitely, more so in the near future. If you go out to wcf.codeplex.com, that is the site where they are doing the development of this thing I referred to as WCF jQuery, which is basically a RIA Services implementation for JavaScript for HTML clients. So you would be able to have a very similar experience of working with a context object that you make the calls through and having jQuery or JavaScript generated data types that you can populate with those calls with some client-side jQuery support to tie into jQuery binding and stuff like that. So I would definitely check out the WCF jQuery if you're an HTML developer. Next one here, and then we'll wrap up, is the context variable always update, let's see, up to date. Oh, the context always up to date, or do we need to refresh it? The context variable, if you're talking about the one on the server side, it does cache things in memory, so it's as up to date as your last query. The one on the client side is as up to date as your last load call. So it's kind of symmetric there on the client and server side, that they cache the data that they retrieve. They don't know anything about changes to that data from the the next hop over, whether it's the database on the server side or the server on the client side. It doesn't know about any changes there unless you make a load call on the client side or make a query against the database on the server side. Just two more quick ones here and then wrap. There's a question about MySQL and Code First. I don't know much of anything about MySQL myself. Whatever your query data access query patterns are for MySQL, you would just put those in your CRUD method, similar to what I was doing with the DB context stuff. And then another question similar, will these techniques work within Hibernate? Absolutely. Just that data access code and the CRUD methods in your domain context would make in Hibernate calls instead of DB context calls. All right, with that, I've got all the ones answered in the queue. We're out of time. I'm going to hand it back to email, and if there are follow-on questions, feel free to ping me by email.
Okay, thank you, Brian. Any questions that we didn't manage to address will be replied personally by email. And just before we leave, we have some more gifts for you. Fill in our post-webinar survey, and you can win 3 free ebooks on WCF RIA Services. A recording of this webinar, as well as all the demos and slides, will be made available to you and emailed within the next 2 days. So with that, thanks for attending and have a good day or night.